Hey guys, it's Rue here with Math Heroes. So today I'm going to be continuing going through the NECA Level 2 2017 paper. So yes, I'm going to be going through the Level 2 Mathematics and Stats paper for 2017. So code is 91262. Excuse me. Um, so you apply calculus methods to solving all problems. Okay, so moving on. So we will be going into question number 2a. So for question number 2a, the diagram below shows a graph of a function y equals to x, and we've been asked to sketch the graph of the gradient y is equals to f naught x, or the first derivative, or f cap x. Sorry, not f naught, but f cap x, or the first derivative of the function. Okay, so we can see that this is a concave graph, right? So it's a concave graph. So if we have a concave graph and it's an x squared graph, as we can see, because there are two values for x, right? Here are the two solutions for x, which seem to be -3 and 2, right? Those are the two solutions for x. Anyhow, since we have a concave graph like this, and we know that's the graph for x squared, so we know that our function f of x, right, is equal to minus x squared, right? And what we've been asked to do is to find the first derivative, so f cap of x, right? So how do we find f cap of x? We simply differentiate this. So f cap of x, right, is equal to minus 2x, right? Which is also our function y. So y is equal to minus 2x, right? And we've been asked to find, to plot, right, the graph, or sketch it rather. So we're gonna do that. So, right, very simple. We sketch it according to our first principles of how to sketch graphs, right? We've got your y, you've got your x, then we'll have a couple of values, right? So what we'll do is we'll select a certain value for x and find out what y is, and once we fill our coordinates, we'll just plot those points and then connect the line, which is easy peasy. Should be, I think, level 1 stuff. Okay, so moving on. Okay, so we want to know, let's say, for example, x is equal to minus, excuse me, x is equal to minus 2, right? If x is equals to minus 2, y is equal to 4, right? If x is equal to minus 1, right, y is equal to 3, right? If x is equal to 0, right, if x is equal to 0, y is equal to 0, right? Which means that the graph passes through our point here, passes through our center point, I believe. Okay. And what else? If when x is equals to 0.5, right? When x is equals to 0.5, y is equal to what? Y is equal to minus 1, right? Agreed? And when x is equal to 1, right? Y is equal to minus 2. And when x is equal to 2, y is equal to minus 4. Okay. So we're seeing that our graph will move in this direction, right? So what are we saying? For x is equal to minus 2, right? Y is equal to 4. So where is x minus 2? X minus 2 is here. Where is y is equal to 4? So we're saying it's going to be 1, 2, 3, 4, right? And then it's going to be 1, 2. So we've got a point here, right? We've got a point here. One of our points are here, right? What is our other point? Our other point is minus 1, 3, right? So we've got another point here, right? Where is our other point? Our point is 0, 0. So we've got a point here, right? What is our other point? Our point is when x is 0.5, right? Y is equal to, or y is equal to minus 1 when x is 0.5. So we've got another point here, right? When x is equal to 1 or y is equal to 2. So this is 1, 2. So we've got another point here, right? So we can see we're creating a line here. When x is equal to 2, 1, 2, y is equal to 4, somewhere here, right? So as you can see here, got a line. Okay, I can't draw this properly, but I'll try my best. So we're just trying to catch all these points. Oh, that was not as good. So in a sense, this is what the line will look like. But obviously you have a ruler so you can straighten it out. But in jest, this is what we expect the line to look like. So if you draw something like this, you will get 4 marks. You show your differentiation, how you got it. I don't really know if this is necessary, but this was just to illustrate where I'm getting the values and not just, put on a straight line, as you can see. So you wouldn't want to draw a line that looks something like this because that wouldn't be correct. So you need to be guided by the points. So I'm sure if you plot in your points, you even get marks to show, because it shows that you have an understanding of what we're trying to show or what we're trying to communicate. So yeah, I think I've spent more than 5 minutes on this question. So let's move on. Okay, so moving on to question 2b. Okay, so the graph of the function f of x is equals to 2x cubed plus bx squared minus 2 and has a turning point when x is equal to minus 1. Find b. Okay, so what we want to do is, if it has a turning point there, which means that when we differentiate this to find the gradient function and we substitute in x for 1, it will be equal to 0, because basically what they're saying graphically, I'm sorry, I'm obsessed with graphs. Graphically what they're saying, let's say this is like a cubed, right? They're saying that it's at this point, and at this point we've got, oh sorry, it's negative, so it will be at this point, right? So at this point we've got minus 1, and the gradient is flat here. That's basically what they're saying, right? So yeah, so what we do is we just find our f cap, right, which is equal to 6x squared plus 2bx. So yeah, that's it. This is nothing else there, because we well, minus 0 if you want, because this becomes a 0, so it's equal to 6x squared plus 2bx. Excuse my handwriting, right? And then we're saying that when we substitute this, right, f cap of x of this should be equal to 0 when x is equal to 1, right? When x is equal to minus 1, sorry. So what we're saying is this is equal to 0, right? 6 minus 1 squared plus 2b minus 1, right? So and then this becomes minus 6. Oh, sorry. So it remains plus 6 minus 1 squared is 1. Let me just write this so that it makes a bit more sense. It's coherent. Let me just remove. Okay. So this then becomes 6, right? Minus 2b. Because minus 1 squared is 1, and then this negative multiplies into everything and makes it negative. So, and then what we have now is 6 is equal to 2b. And then, so b is equal to 3. So you can see what happened here. So what happened is minus 6 went to the other side and became minus 6 and minus, and I just multiplied the negative both sides. Or if you want, you can say that the b goes to the minus 2b goes to the other side and becomes positive. It makes no difference. It's entirely up to you, right? But yeah, that's the gist of it. So b is equal to 3. And then that's it. That's how you find the value of b. And I think number 2b is done. So let's move on. And I did that in 3 minutes. Okay, so let's move on to 2c. So use calculus to show that the line y is equals to line y equals to 15x minus 12 is the tangent of the graph. Okay, so first things first, what do we know? Okay, what we know is if we differentiate this, we will get what the gradient function is, right? The gradient function, that should be equal to 15. Okay, so let's differentiate this. So if x cap, right, is equal to 8x right? Minus 1. And we know that 15, right, is equals to 8x minus 1, right? So we want to find out what x is, what value of x we have. So we just want to find out what one of the points are at that point, what the coordinates are at that point where the line passes through. Okay, so what do we do? It's going to be 16 is equals to 8x. Therefore, x is equal to 2, right? And at the same time, if we want to find out what y is, we just go and substitute this into here. That's basically what we do. That's all we need to do, right? So if we do that, what we will get is we'll get so f of 2 is going to be equal to 4 2 squared minus 2 plus 1. It's going to be equal to 4, okay, 4 by 4 minus 2 plus 4, which is going to be equal to 16 minus 2 plus 4, which is equal to 18. That is y. So y is equal to 18 and x is equal to that. All right. And what do? We know that y, right, minus y1. I think we've done this a lot, right? X minus x1 is equal to m. And we know, so y minus 18, right? Y minus 18 over x minus 2 is equal to 15. Okay, so that's y minus 18, right, is equal to 15 multiplied by x minus 2, right? So this is going to be y minus 18 is equal to 15x minus 30. Okay, so what happens then? This becomes y is equal to 15x minus 30 minus 18. Oh, y is equal to 15x. This becomes plus 30, my bad. So 15x minus 12. We have proven. Then I would write shown, because I thought I was that guy. I would write shown. Yeah, back in the day. And then it's done. And that is how we solve C. Yeah, so let's move on. Okay, guys, so let's move on to 2D. So for 2D, use calculus to find the value of k if the line y is equals to 6x plus k is the tangent of the graph of the function fx is equals to x squared plus 2x minus 1. So k is just a constant that we need to find, right? In this equation, it will be the c. So it will be y is equals to mx. Good Lord, let me write that correctly. Okay, so it'll be y is equal to mx plus c. So we're looking for the c, which is the intercept when x is equals to 0. What is y? So it's the y intercept. Anyway, so what do? We do like what we did for the previous. So what we want to do is we already know our gradient is 6, right? So we differentiate this so that we can find our gradient function, so that we can find our value for x. When you find our value for x, we find our value for y, and then we simply simplify that using our gradient equation to find out what c is. So that's very simple. So let's do that. I've already explained it to you. I'm not going to take too much time anymore because I've explained to you, and it's similar to what we did before. So it's going to be 2x, right? 2x plus 2. That is equal to 6, right? So 2x plus 2, right? So we've got what? 4 is equal to 2x, right? So x is equal to 2. Then we substitute 2 into our equation. What do we get? F of 2 So this is going to be equal to 4 plus 4 minus 1, which is equal to 7. So y is equal to 7 when x is equal to 2, right? Now we have our equations. Now we can simply use our formula. We know y minus 7 is going to be over x minus 2, and that is going to be equal to what? It's going to be equal to 6, right? So y minus 7 is equal to 6 multiplied by x minus 2, right? So y minus 7 is equal to 6x minus 12, right? So y is equal to 6x minus 12 plus 7. So y is equal to 6x minus 5. Therefore, k is equal to minus 5. Done and dusted. And that is how we do that. So yeah, that's it. Let's move on. Hi guys, so we're gonna do number question 2e. So question 2e has a couple of methods you can go through it, but I'm just gonna go through the easiest one. Okay, so use calculus to prove that the graph of the function y is equals to x cubed bracket 3 minus x has a local maximum when x is equals to 9, when x is equals to 9 over 4. Okay, justify that the turning point is a local maximum or minimum. Okay, so how do we do this? So there are two methods. There's a method where you can find the first derivative and then check to see if the sign is changing with the value of x so that you can find out if it's a local minimum or maximum. I think I have mentioned that before in my previous lectures. In my previous walkthroughs, I think for the 2004 paper, I think I mentioned that in depth. But today I'm going to just try and teach you a simpler method, or let's try and use a quicker method if you're in an exam. So what you can use is the second derivative test. So there's a law, right, or a rule, right, that the second derivative for this function, right, if it is less, right, if it is less than 0, right, so we're going to say y, right, of x, y double cap of x, if it's less than 0, then it is maximum, right? Then if y double cap of x, right, is greater than 0, then it is a minimum, right? So given the exam situation, this is what I'll probably do, and I'll just find the second derivative. So what is the first derivative for our function? The first derivative, simplifying this, okay, hold on, let's not get ahead of ourselves. So first and foremost, because I don't want you guys to get lost, so simplifying this, what we would get is it would be equal to y, right? Y would be equal to 3x squared, 3x cubed, sorry, minus x to the power 4, right? So the first derivative, so let's say y cap of x would be equal to 9x squared minus 4x cubed, right? And from what we're saying is when we substitute this out, right, when 9, so y of 9 over 4, right, so we've got 9 over 4 squared here. Most probably need to pull out your calculator to prove this, right? 4, we've got 9 over 4 here cubed, right? So this should be equal to 0, right? So you can quickly work that out and prove that out. Should be equal to 0. But what we're saying is that second derivative, right, which is going to be 18 x squared minus, oh sorry, there's no squared here, it's just going to be 18x. What's the rubber? Let's rub that out. So rubbing this out, right? Hold on. Then it's gonna be minus 12 x squared, right? So when we substitute in 9 over 4 into this, right? So 18, got our 9 over 4 here, right? Minus 12 We've got our 9 over 4 here, right? To prove that this is a maximum, right? This should be less than 0, right? So what do we get if we simplify that? Okay, I'm just going to quickly use my calculator because I think I'm too old to try and. So what is 9 over 4? So 9 over 4 squared, right, is 16 multiplied by 12. That's 6.75, right? And then what's 18 times 9 divided by 4, right? Okay, so from what I'm getting, right? 1, 9 over 4. Okay. Uh-huh. Okay. Okay. Subtract 18 times 9 over 4. Right. So the answer I'm getting is minus. When I simplify this, right? The answer I'm getting is minus 20.25, which is less than 0. So yes, it has a local maximum. And that is how I would do it. I would use the second derivative test. It's quicker, it's easier, it's cleaner, and you'll quickly get to your answer. You could use the other method where you put in values into this second derivative. So you perhaps make x 0 and see what you get, and see if the graph is changing signs so that you can figure out if it's a local minimum or maximum. But that would take way too much time. This is quicker, this is easier, this is simpler, and it's got less steps. So yeah, that's what I would do. So yeah, I think that's the gist of it. And yeah, this is it for question number 2. I will see you guys in question number 3. Bye.